Okay, let's unpack this. Imagine for a second just sitting at your desk and watching your computer mouse move completely on its own.
Oh yeah, just total ghost in the machine stuff.
Right. It clicks into your file directory, it opens up this dense Python script, and it just starts scanning through hundreds of lines of code. It finds that one logic error you've been banging your head against for like 3 straight days.
Yep, we've all been there.
And then it just rewrites the function. You run the terminal command to test it and stages a git commit, all while you are literally just sitting back, drinking your coffee with your hands completely off the keyboard.
It sounds like a total security nightmare.
Exactly, like a terrifying hack. Right. But today, we're looking at why that exact scenario is, well, it's actually the very near future of software engineering.
It really is.
We're taking a deep dive into how artificial intelligence is fundamentally breaking out of the web browser. I mean, it is moving way past being just a simple chat interface where you ask a question and get a text response.
Right, the old paradigm.
Yeah, and it's transforming into this agentic thinking partner. Specifically, our mission today is to analyze how Anthropic's Claude is stepping in to assist developers with incredibly complex technical project workflows.
Which is a huge leap.
It is.
Yeah.
We're talking about taking messy whiteboard sketches and turning them into interactive prototypes. We're talking about directly editing code on your local desktop. And we're going to explore how it does all of this while being governed by a very strict internal rulebook.
And to ground this entire conversation, I want to make sure people know we aren't just speculating here.
Right.
We are drawing exclusively from Anthropic's own internal training material. Specifically, we're looking at a course document called whatisclaude.pdf.
Which is essentially their Claude 101, right?
Exactly. It's their baseline training. It outlines not just the raw capabilities of the system, but the fundamental design philosophies, the actual mechanisms behind how it operates. If we connect this to the bigger picture, imagine standing in a modern, high-tech architectural drafting room.
Okay, I like that.
You have the raw structural materials of code over here. You have the visual user-facing design of interfaces over there. And now you have a system that can weave them together autonomously. That is the environment we are analyzing today.
I love that visual.
Right.
Digital drafting room. But, before we get into the really flashy stuff, like how this thing actually builds apps and writes code, we kind of need to address the elephant in the room.
The security aspect.
Yeah, because that scenario I painted at the beginning, handing over the keys to my local environment, letting an AI run terminal commands, if I'm a senior developer, my immediate reaction is just sheer panic.
Oh, absolutely.
Like, if you're going to trust an AI with your company's proprietary code base, you need an ironclad guarantee it's not going to go rogue or hallucinate some malicious script or, I don't know, accidentally delete your production database.
Exactly. And that is the critical first step. I mean, you cannot have autonomy without trust. And you cannot have trust without predictable guardrails. The source material emphasizes that Claude is built on a foundational framework called constitutional AI.
Constitutional AI. Okay.
Yeah. At a high level, this is a mechanism designed to ensure that the AI's outputs are helpful, harmless, and honest.
Right, but I'm going to push back here for a second.
Sure.
Because helpful, harmless, and honest sounds great on a glossy marketing brochure. But what does that actually mean under the hood? I mean, standard AI models just predict the next most likely word based on their training data.
Yeah, next token prediction.
Right, so how do you force a statistical model, to be honest? It just feels like a buzzword.
It's a great question, and to understand it, we really have to look at the mechanics of how it's trained. Because historically, AI models relied heavily on RLHF, which is reinforcement learning from human feedback.
Okay, the human feedback loop.
Right. Humans would look at 2 AI answers and say, this one is safe, this one is toxic, and the model would slowly learn from those human preferences, but humans are slow.
And biased.
Exactly. Human bias creeps in constantly. So constitutional AI shifts this entire paradigm. Anthropic literally gives the AI a constitution, like a set of explicit written principles.
Wait, really? Like a literal document?
Yes, a written rulebook. During its training phase, the AI generates a response, and then it is forced to critique its own response against that constitution.
Oh, wow.
So if it detects that its output violates a principle, say, it realizes it just generated code that could be used for a cyber attack, it revises its own answer before it ever gets any human feedback.
Wait, so it's evaluating itself. It's basically running an internal compliance check on its own thoughts before it speaks.
Precisely. It's called RLAI, or Reinforcement Learning from AI Feedback.
Yeah.
It builds this internal model of what is permissible and what is not.
That's wild.
It is, and for technical teams, this is exactly why it matters. When you deploy an AI in an enterprise setting, you aren't just crossing your fingers and hoping it behaves. Because of constitutional AI, the system is actively trained to refuse to help humans engage in illegal activities. And it's trained to avoid generating data models with inherent discriminatory biases. It operates transparently, and it aligns with human values on a structural level.
So if I'm hearing this right, constitutional AI is less like a standard terms of service agreement you just blindly click agree to,
Yeah.
and more like baking an ethics board and a senior engineering manager directly into the AI's brain.
That is a highly accurate way to frame it. You are internalizing the oversight mechanism. It's built into the foundation.
Yeah.
And the training document also highlights that this structural foundation makes the system uniquely steerable.
Steerable. Okay, meaning what exactly? Like I can tell it to talk like a pirate while it codes?
I mean, you could do that.
Right.
But in an enterprise context, steerability means you can give it a highly specific system prompt defining exactly how you want it to behave, and it will adhere to those parameters relentlessly.
Oh, I see.
So you can say, you are a senior React developer, you only write strictly typed TypeScript, you never use inline styling, and you must prioritize execution speed.
Okay, so setting strict boundaries.
Exactly. And because adherence to instructions is part of its core constitution, it won't just drift from those rules halfway through a long project.
Right, it won't get lazy.
Exactly. For enterprise users, this steerability translates directly into predictability. You know exactly what you're going to get.
That is massive for anyone listening who is, prepping for a meeting about AI integration right now. That is the exact language you need to assure stakeholders about risk management.
Absolutely.
You aren't bringing in this black box that might randomly rewrite your server architecture in the middle of the night.
Mm-hmm.
You're bringing in a highly steerable system governed by a hard-coded constitution.
Right.
But all right, let's pivot a bit. Here's where it gets really interesting. Because that constitutional AI guardrail isn't just theory, right? It is the exact reason a developer can feel safe handing over the keys to their actual desktop.
Exactly.
Because if we look at how this operates in the trenches, we really have to talk about Claude Code.
Yes. This is where we move from theory to actual practice. The source document introduces Claude Code, and the defining word they use here over and over is agentic.
Agentic.
Yeah, it is an agentic coding tool designed specifically for developers.
Okay, agentic is definitely one of those buzzwords flying around every tech blog right now.
Yeah.
We need to unpack what that actually means, mechanically speaking, compared to what we've all been using for the past couple of years.
It's a crucial distinction to make. We really have to separate an assistant from an agent.
Okay.
An assistant waits for you. Think about it. Most developers are used to web chatbots. You have a bug, you copy your code, you flip over to the browser, paste it in, ask the chatbot what's wrong, and it generates a little snippet of text.
Right, and then I have to do the work.
Exactly. You, the human, have to copy that text, paste it back into your code editor, run the terminal command to test it, see if it works, and save it. You are the engine of action in that scenario.
Right, the AI is essentially just a really smart dictionary that I'm consulting.
Exactly. But an agent takes independent actions within a bounded environment based on a high-level goal you give it.
Independent actions.
Yeah. Claude Code doesn't live in a browser window. It exists directly on your desktop, right in your local development environment.
Wow.
It performs actual file manipulations. It can directly edit your files. It can run terminal commands, and it can even create commits for version control. It operates on what we call an agentic loop.
An agentic loop.
Yeah. Reason, act, observe.
Okay, hold on. Let's play out a scenario here so I can really understand this loop.
Sure.
Let's say I'm building a web app and my user login authentication is completely broken. It's throwing a 500 server error, and I have absolutely no idea why.
A classic headache.
Right. What does Claude Code actually do when I just type, hey, fix my login?
Okay, so in that scenario, you give the high-level prompt, fix the login 500 error. First, it goes into the reason phase. It knows it needs to find the authentication logic. Second, it acts. It autonomously searches your local directory, opens the relevant routing files and maybe your database schema, and it reads them.
Just on its own.
On its own. Third, it observes. It analyzes the code it just read, identifies that, oh, you have a mismatched token validation, and it rewrites that specific block of code right in your file.
It actually edits the file.
Yes, and then the loop repeats. It acts again by running a test command in your terminal to see if the 500 error is gone.
Oh, man.
Then it observes the terminal output. If the test passes, it prepares the Git commit for you to review.
Okay, that is incredible. But again, as a developer, the idea of an AI unilaterally running terminal commands on my local machine is kind of terrifying.
It is a lot of power.
Yeah, I mean, if you can run a test script, what stops it from running a command that accidentally drops my entire user database?
Yeah.
How is this bounded? Like, is it basically just a junior developer sitting inside my computer running wild?
That's exactly where the human-in-the-loop concept and that steerability we discussed come into play. It doesn't operate blindly. It explains its intended actions to you.
Oh, yeah.
And for any destructive or high-stakes commands, it actually waits for human approval before executing.
So it pauses and asks.
Exactly. But more importantly, the reason it doesn't just flail around and break things randomly is because it has a holistic understanding of your entire project architecture.
How does it know the whole architecture, though?
Well, to understand how it achieves that, we have to look at another capability mentioned heavily in the sources. And that is its massive context window.
The context window. That's essentially the memory of the AI for that specific conversation, right?
Correct. It's the short-term working memory. The intelligence-driving Claude code has a context window that can ingest 200,000 plus tokens.
Which is huge.
It is. To put that in perspective, 200,000 tokens is roughly 500 pages of dense text.
Wow.
And it gets better. On the Pro, Max, Team, and Enterprise plans, that scales up to 1 million tokens.
1 million tokens. Okay, we need to marinate on that for a second because I hear tokens all the time.
Here.
And I think people just assume one token equals one word. That's not quite right, is it? What actually is a token to an AI, and how does 1 million of them change my workflow?
It's a really fundamental concept to grasp. A token is essentially a chunk of a word or a fundamental unit of meaning.
Okay.
For example, the word hamburger might be split into ham, burr, and gur.
Ah, I see.
The AI doesn't read English the way we do. It reads a massive geometric map of how all these tokens relate to each other. So when we say 1 million tokens, we are talking about a truly vast amount of data being held in the AI's active short-term memory all at once.
Wait, so if I have 1 million tokens, I could theoretically dump my entire company's API documentation, plus like 3 years of Slack messages between my engineering team and the entire backend code base of my application into one single prompt, and it just remembers all of it.
It doesn't just remember it, it can actively synthesize it. And this solves a massive technical hurdle in AI called the needle in a haystack problem.
The needle in a haystack.
Yeah. In older models, if you gave it a massive document, it would forget information that was buried in the middle. It would basically only remember the very beginning and the very end of your prompt.
Oh, right, like when you read a long book and forget the middle chapters.
Exactly. But Anthropic has engineered their models to have near-perfect retrieval across that entire 1 million token span.
So it can actually find the needle.
Exactly. So when Claude Code makes a change to a single line of code in your login file, it isn't doing it in a vacuum. It is holding your entire massive code base in its memory.
That's crazy.
It understands that changing this one login variable right here is going to impact a user dashboard component 3 folders away, because it's actively holding both of those files in its context window simultaneously.
That completely changes the paradigm of debugging. I mean, it's the difference between trying to fix a car engine by looking through a keyhole with a tiny flashlight versus taking the entire engine apart, laying every single gear out on the floor, and seeing exactly how they all connect.
That is a perfect analogy. It has the macroscopic view and the microscopic capabilities simultaneously.
Okay, so code is obviously a massive part of this, but code is really only half the battle of building software, right?
Very true.
Because code handles the back-end logic, the infrastructure, all those hidden gears.
Oh.
But technical projects are deeply visual.
Oh, absolutely.
You have product managers, you have UI, UX designers, you have stakeholders who don't know what a Git commit is, but they know what they want the app to look like. So how does the rest of the product team actually interact with this workflow?
The sources address this directly with a feature called Claude Design.
Claude Design, okay.
Yeah. This is described as a dedicated space specifically for turning ideas into working interfaces. And this is where the friction between the visual concept and the executed reality truly disappears.
Right, because historically getting an idea out of a product manager's head and onto a functional screen is just an absolute nightmare of bottlenecks.
It is notoriously slow. I mean, typically, a product manager draws a rough sketch on a whiteboard.
Yeah, with a dying marker.
Exactly. They take a blurry picture of it, they send it to a designer who spends days recreating it in a vector design tool like Figma or something.
Right.
Then, that static design gets handed off to a front-end developer who has to spend more days writing all the HTML, CSS, and JavaScript just to actually make it clickable and functional. Claude Design collapses that entire timeline from weeks to literally minutes.
But how? I mean, how does a machine go from a messy whiteboard doodle to functional code? That honestly just feels like magic.
It does, but it's not magic. It's advanced multimodal AI processing.
Multimodal.
Right. We often think of AI as just processing text, but Claude has highly sophisticated vision models. When a user provides a sketch or a screenshot, the AI isn't just looking at a flat image.
What is it doing then?
It is processing the pixel arrays, detecting edge patterns, and recognizing bounding boxes.
What?
It correlates those visual patterns with its vast training data of what UI elements actually look like in code.
Oh, I get it.
So it sees a rectangle with text inside and understands structurally that is a button. It sees a grid of images and understands, oh, that is a masonry gallery layout.
So it's extracting the structural intent behind my terrible drawing.
Exactly. The user can start by simply describing what they want, or they can just upload that rough sketch. Claude ingests that visual information, understands the intent, and instantly generates the underlying code.
Just instantly.
Yeah, it writes the React components and the Tailwind CSS to build an actual interactive prototype. You aren't getting a static image back. You are getting an interface where you can actually click the buttons.
Wow.
You can see the layout respond when you resize the window. You can test the user flow. And from there, you can iteratively refine it through natural language. You can literally just say, hey, make the navigation bar sticky, and it updates the code instantly.
It's like having a universal translator who speaks both messy whiteboard doodle and functional user interface.
That's a great way to put it.
You just upload the napkin sketch, and it spits out something you can actually interact with.
A universal translator is a brilliant way to conceptualize it. And if we think about the team dynamics here, the implications are staggering. A designer or a product manager is no longer handing a static, lifeless image to a developer and saying, here, build this.
Right.
They are handing over a working, interactive prototype.
And wait, let's connect the dots here. If the PM is using Claude Design to generate the interactive front end, the developer, who, remember, is now using Claude Code, can take that functional prototype, bring it into their local desktop, and have Claude Code immediately start wiring it up to the back-end database.
Precisely.
You're entirely changing the speed and the language of technical project handoffs.
You are democratizing the prototyping phase. You don't necessarily need to know how to write front-end code to show your team exactly how an app should feel and behave. You are communicating through functional software from day one.
That is wild. Okay, so we've seen how it codes with these agentic loops, and we've seen how it designs with multimodal vision. But workflows aren't just about output, right?
No, not at all.
We are just factories churning out code and interfaces. A huge part of any technical job is problem-solving, strategizing, and frankly, just learning how to do things you've never done before.
Absolutely.
So how does the system adapt when the problem gets highly complex, or when the human using it actually needs to learn the ropes instead of just having the machine do the work for them?
This is where we look at the broader ecosystem of the AI's cognitive modes. The training material outlines two very distinct, highly specialized capabilities that address this.
Okay, what are they?
The thinking capability and learning mode.
Let's dig into the thinking capability first.
Yeah.
Because AI already thinks, right, like in quotes. What makes this a distinct mode?
What's fascinating here is that it represents a deliberate, fundamental shift in AI design philosophy. For a long time, the holy grail of AI was just instant response.
Right, speed.
You ask a complex question, it replies in a millisecond. But for incredibly complex cognitive tasks like advanced mathematical proofs or multi-step strategic analysis, instant speed is often the enemy of accuracy.
Because it's just guessing the next word as fast as it can, without planning ahead.
Exactly. It's that next token prediction we talked about. But the thinking capability changes this by utilizing what we call test time compute.
Test time compute.
Yeah. When you toggle this mode on, Claude takes time to reason step by step before it outputs a final answer.
Oh, so it pauses.
It does. It mimics human deliberation. Internally, it is generating chains of thought. It's evaluating different approaches, recognizing when a path is a dead end, discarding it, and correcting itself before it ever shows you the final result.
So it's essentially saying, hang on, let me map this out on a mental whiteboard instead of just blurting out the first statistical probability that comes to mind.
Exactly. It sacrifices instant gratification for deep, rigorous accuracy. It is actively allocating computational power at the moment of inference to truly solve the problem, rather than just relying on what it memorized during training.
That is a huge distinction.
It is. And then, complementary to that problem-solving engine, is the new learning mode.
Right, the sources say this adapts to your learning style and pace. But my fear with AI has always been that it's going to make us lazy.
That's a common fear.
If the AI can just write the perfect React component, why would a junior developer ever learn how to write React? They'll just become prompt engineers who don't actually understand the code they're deploying. So is learning mode basically forcing developers to eat their vegetables instead of just doing their homework for them?
That is a very real industry-wide concern, and learning mode is specifically designed to counteract it. It guides a user's reasoning process rather than just providing the answers. I know some people say it's like forcing developers to eat their vegetables, but I think a better analogy is a gym spotter.
A gym spotter. Okay, I like that. Unpack that for me.
If you are at the gym trying to bench press a heavy weight and your spotter just reaches down and lifts the entire bar for you, you haven't built any muscle.
Right, you haven't done anything.
You haven't gained anything, and AI just spitting out the final code is lifting the weight for you. But a good spotter doesn't lift the bar. They keep their hands hovering, they provide just enough stabilization so you don't crush yourself, and they force you to push the weight up.
Ah, I see.
That is what learning mode does.
So if a developer is trying to learn a new programming language or understand a complex architectural pattern they've never seen before, learning mode won't just write the code for them.
No, it won't.
It will prompt them, ask them questions, point out logical flaws in their approach, and basically help them develop the critical thinking skills to arrive at the solution themselves.
Precisely. It acts like a Socratic tutor, because Anthropic's philosophy here seems to be that knowledge is most valuable when it is deeply understood and applied, not just copied and pasted.
Yeah, that makes sense.
By acting as that cognitive spotter, the AI is ensuring that the human remains a highly capable critical thinker, rather than becoming this passive operator who is overly reliant on the machine for basic tasks.
It really feels like the end of the just give me the answer era of AI, at least when you want to actually build your own skill set. And it seems like they want this intelligence everywhere you work. I noticed the sources mention integrations that bring this right into the daily grind outside of just the coding environments.
They do. The ecosystem extends way out into general enterprise workflows. They highlight Claude tag, which brings this intelligence directly into Slack.
Oh, nice.
You can chat with it in channels, in direct messages, or by tagging it in threads. And crucially, because of that massive context window we discussed earlier, it actually searches your workspace as shared files and chat history to find context. It's not answering in a vacuum.
So it's reading the room, essentially.
Yeah.
It knows what the marketing team debated in a Slack thread yesterday, and it can apply that context to the problem the engineering team is solving today.
Exactly.
And the sources also mention Claude for Microsoft 365, which puts this capability as a sidebar in Excel, Word, and PowerPoint, carrying context from one app to the next.
It creates a unified intelligence layer across the entire enterprise stack. It is everywhere you are.
You know, for anyone listening to this deep dive right now, I highly suggest doing the lesson reflection that was actually mentioned in the Anthropic source material.
Oh, yes, that's a great exercise.
It's a brilliant way to conceptualize this shift. Take a look at your calendar right now. Look at your tasks for the upcoming week and just categorize them. Identify which ones require learning mode, like building a new skill where you need a spotter,
Right.
versus tasks that require thinking mode, where you need the AI to sit down, take its time, and solve a highly complex strategic problem, versus tasks for Claude design, where you just need to rapidly prototype a visual idea for a stakeholder meeting.
It is a very practical exercise in resource allocation. You are no longer just learning to delegate to an assistant.
Right.
You are learning to delegate specific types of cognitive labor to the most appropriate mode of the AI ecosystem.
It really is a whole new way of working.
Let's summarize the sheer ground we've covered today, because it's a lot. We started by looking at the foundation. We established that Claude is no longer just a chat window you visit on a website. It is a comprehensive ecosystem.
Yes.
It is guided by the strict, predictable, self-evaluating rules of constitutional AI, which is what makes it fundamentally safe for high-stakes enterprise use.
Crucial point.
We looked at Claude Design, which uses multimodal vision processing to translate messy sketches into interactive functional prototypes, completely eliminating historical design bottlenecks.
Right?
We broke down Claude Code, this agentic tool that lives on your local desktop, independently running reasoning loops to edit and commit files with a macroscopic understanding of your entire code base.
All thanks to that million token context window.
Exactly. And we explored how it uses test-time compute in thinking mode to deliberate on complex strategies, and a Socratic learning mode that acts as a cognitive spotter to teach you rather than just doing the work for you. It really is a fundamental paradigm shift in how technical work is executed. We are moving from a world of manual construction to a world of guided, autonomous generation.
Well said.
And this raises an important question, something we should probably leave our listeners to mull over as they look at their own workflows tomorrow morning.
Let's hear it.
We've established that Claude Code can act agentically to manipulate local files and run commands autonomously.
Yeah.
We've established that Claude Design can instantly turn a rough sketch into a working prototype
Right.
with an AI guided by a self-policing constitution, operating with a million-token context window that can hold entire software repositories and company histories in its active memory. We have to ask,
Okay.
in the technical workflows of the very near future, does the AI become the primary engine of development, making the human engineer entirely a manager of AI agents rather than a writer of code?